Imagine that you find out about a great internet service where you can get all your dairy products delivered directly to your house at a significant discount. The only hitch is that you have to sign up once and specify a weekly quantity of each item, and the company will only guarantee that the delivery will come sometime during the week. The company has to schedule weekly shipments of goods to its warehouse, so it wants advanced orders locked in to make sure it sells all inventory that it receives. They will leave it on your front porch in a thermo container so it will stay cold. You specify a typical quantity of eggs and milk and butter that you need in a week, but you are not sure what day of the week the products will come. It may be Monday, but it could be Friday. So you will need to keep enough of all dairy products in your refrigerator to get you through the week. And if the delivery comes on Monday, you will have a refrigerator full of a week's worth of dairy products plus what comes on Monday. Too much to fit in one refrigerator. So you will need to buy a second refrigerator and put it in the garage. And if you go on vacation and happen to forget to cancel the order for that week, you will have a week's worth of bad dairy products on your front porch when you return. This is an example of an inventory push system. In business, goods and services are often pushed onto the retailer, whether or not the retailer can sell them right away. The retailer tries to push them onto you, whether you need them right now or not. And the result is a lot of inventory of stuff that you do not need to immediately use. And most likely the retailer is also holding a boatload of inventory themselves. Now imagine the internet service gets a lot of complaints and upgrades its service. They send you a wireless device that has buttons on it for each of your dairy goods. When you open a new bottle of milk or a new carton of eggs, you push the button for that item. The next day, they deliver 1 unit to replenish what you started using. This means you will have the partially used unit if you did not finish it, plus 1 more. Some inventory, but not a lot. If you think you will be using a lot of a product, like milk, then you can get on the internet or even pick up the phone and they will immediately deliver what you need. On their end, they have renegotiated agreements with their dairy suppliers. When the customer orders more product, that will trigger a signal to dairy companies to send that amount to the retailer. This is an example of a pull system. You receive items only when you demand them, and the retailer receives products based on actual customer demand. To avoid having items pushed on you, you might even be willing to pay a little more for this on-demand service. Many companies and service organizations within companies work to their own internal schedule. They do what is convenient for them within that schedule. So they produce parts, goods, and services according to their schedule or plan and push products onto their customers who have to stockpile it in inventory. As you already know, the Toyota way is not about managing inventory. It is about eliminating it. Very early on, Toyota started thinking in terms of pulling inventory based on immediate customer demand, rather than using a push system that anticipates customer demand. In the Toyota way, pull means the ideal state of just-in-time manufacturing. Give the customer, which may be the next step in the production process, what he or she wants, when he or she wants it, and in the amount he or she wants. This passage was from the book The Toyota Way, 14 Management Principles from the World's Greatest Manufacturer by Jeffrey Liker. Jeffrey's basically an expert in the Toyota production system. He's wrote numerous books. He's the professor of industrial and operations engineering at the University of Michigan. I highly recommend every single one of his books. I have every one of them myself, and I've referenced this one for about 6 or 7 years, and they're all just jam-packed full of information that we can take back to our medical system and to our laboratory systems and use right away and think about and contemplate on improving. And I highly recommend every single one of his books. Like I said, I hold them all in great esteem if you have an open mind for it. My name is Randy Hall, and I want to welcome you guys to this video. And what I've done in this video is we've created a pull system out of the disposable supplies that we use in the laboratory at any given time. This pull system is more commonly known to Toyota as a Kanban system, and we'll revisit some of the passages in the Toyota Way book so that you can get an understanding of how Toyota uses Kanban system and how I kind of developed this product. Most laboratories, what you'll find is they'll have a bench space like you see right here on our Chemistry 1 bench, and they'll have all their supplies kind of down here on the bench and that you can reach for and use whenever you need it. At the end of the shift, the tech that's on duty may end up filling those supplies. Sometimes what often happens is they leave it for the next shift to fill, and it creates some frustration there. But there's really no particular system around replenishing and replacing supplies that is predictable, on a predictable basis rather. And a lot of your supplies are down here on your bench where they're cluttered and they take up space. One of the biggest ways to free up that space on any bench is to take all your disposable supplies that you're using and hang them on the wall. It's a simple process, and that frees up a tremendous amount of bench space in a lot of instances. Another way is to red tag items that you don't use in the laboratory and just get rid of them. Do something, auction them off on eBay, donate them to laboratory schools or medical schools. Do something to get rid of the supplies that you don't use on a daily basis. Those two things in themselves can free up a tremendous amount of space in the laboratory, and it can aid in starting to develop what's called a Kanban system. And right now I'm going to go back to the Toyota Way book, and we'll see how Toyota uses a Kanban system so we can get an idea of how this works. Kanban means signboard, door plate, poster, billboard, card, but it is taken more broadly as a signal of some kind. Send back an empty bin, a Kanban, and it is a signal to refill it with a specific number of parts. Or send back a card with detailed information regarding the part and its location. Let's read that one more time. Kanban is taken more broadly as a signal of some kind. Send back an empty bin, a Kanban, and it is a signal to refill it with a specific number of parts. Or send back a card with detailed information regarding the part and its location. So we either have an empty bin or we have a card that has a detailed information about what's in that bin and its location. In this particular laboratory, when I set up this Kanban system, we had our bins placed on the wall here. Whenever a part got down to a certain specific line in that bin, or whenever we saw that it was getting pretty low, we would take that bin and place it on the bench. And that was a visual cue for our specimen processor to come around. They came around once about every 15 minutes. It wasn't a perfect schedule because a lot of times they were processing specimens up front, but they had a specific system that they used so that somewhere around every 15 minutes they would take a cart full of supplies. They would go throughout the lab or throughout the cell here, and if they saw that visual cue of that bin sitting on the bench, they would just take that bin and they would replace the parts within that bin. What you see right here, this electronic Kanban system that I created, is an improvement to that process, because what often happened is they would have just a sheet of paper on a clipboard, and they would write down what was parts and what they replaced, and they tried to keep up an inventory that way. This is a step forward from that actual process that they used, because after a while they just kind of got frustrated and they wouldn't record what they needed to record. So in time we really didn't have exactly a pull system that we wanted to improve on, and that we could take further steps to go in that direction. As far as the actual card is concerned with the detailed information, I'll show you here in a little bit. The card says that it's regarding the part and its location. In that instance, you can see this number up here. Each one of these bins had a specific number that was on a label, labeled on the inside of that bin, and what that would tell the person is that this bin has its location on here. So when we go and actually use this system right here, the person would pick up the bin and they would look at that number, and they would come back to the system and say, okay, well, this is in position 118, or this is in position 13, and they would refill that part and go back. And I'll show you how everything works here in a minute. But just know, for instance, that each one of these bins has a unique number, and we use that number for a specific purpose. Toyota's whole operation of using Kanban is known as the Kanban system, for managing and ensuring the flow and production of materials in a just-in-time production system. Even today, in the world of high-speed electronic communications, you can walk into a Toyota factory making and using thousands of different parts, and you'll see cards and other types of Kanban moving about the factory, triggering production and delivery of parts. It is remarkable, simple, effective, and highly visual. Now, throughout the world, companies are learning the power of the Kanban system. They are turning away from sophisticated computer schedules for many parts of the process. While it can seem like taking a step backwards, it has been repeatedly demonstrated that this is a step forward, because a company's inventory goes down while the frequency of having the right parts go up, and all those complex systems for tracking inventory accuracy becomes unnecessary waste. So basically, in a push system, what you have is you're having more samples that are more parts that are pushed on you from your suppliers or your vendors. Basically, what you'll notice over time is that you're going to run out of supplies that you need on some kind of basis. With a pull system like this, or a Kanban system like this, what they found out over time is that oftentimes you'll have the part there when it's needed. You might think that having a stockpile of inventory, well, you're not going to run out when you need a specific part. But we've all been in an instance where we've had to have something in the laboratory and it's not available to us. Well, that might be a symptom of having a push system in place for some supplies that we needed on a daily basis. Pull replenishment in everyday life. One way to demystify the concept of Kanban is by thinking of simple examples of pull replenishment systems in everyday life. Like when you decide to buy gas for your car, does your gas tank get filled according to a schedule? Would you consider simply filling the tank once a week or on Monday morning? I doubt it. If you did, you would find you sometimes really don't need gas on Monday morning, and other times you will run out before Monday. Most likely, when you notice the gas gauge approaching empty, you stop at a gas station. The same pull system behavior goes for most routine things we purchase in our households. The simple trigger is that we notice our inventory is running low on an item, and at some point say, yep, I better go out and get some more of that. We did nothing different here. We created a system around it. We noticed we were getting low on, let's say, pour-off caps. We take that bin, we place it on the bench. That gives our signal cue to our specimen processors to fill that part. They would fill it, they would put it back up. They were supposed to write it down on a schedule, and this system was created so that that particular move would be taken out of the process. And we'll show that here to you here in a little bit. Not everything can be replenished based on the pull system. Some things must be scheduled. Take the example of high-end products like a Rolex, a sports car, or those killer high-tech golf balls advertised by Tiger Woods. Whenever you're buying a special or single-use item, you have to think about what you want, consider the cost and benefits, and plan when to get it. In a sense, you create a schedule to purchase, since there's no immediate need for it. Services are another type of purchase that isn't immediate but has to be scheduled. For example, we recently had our septic tank cleaned. We had no way of telling if it was getting full and needed to be emptied, so we followed the generally recommended and probably inaccurate schedule for cleaning the septic tank, a push system. But now there's a device on the market that you can install that detects how full the septic tank is. When it reaches a trigger point, it indicates through a radio signal when to get it clean. If we invest in that, we can eliminate the need for a scheduling system and replace it with a pull replenishment system, a signal to replenish, actually to empty, based on actual usage rather than a vague guess about usage. What you might find in a laboratory, basically, that you may have to schedule a push system around is your instrument parts. You don't know when these instrument parts are going to go bad, but when they do, you're going to want to have something there to replace it with. Sometimes we might have to call service engineers to come in and take a look at our analyzers and kind of maintenance them and fix them if that needed to be the case. And sometimes we'll find that we don't have the part that we need on hand. So in that particular instance, well, we might have to sit down and think one day, okay, well, we may need these parts, so let's go ahead and keep a number of inventory on hand. So that's not exactly a pull system, and so we couldn't create Kanban around that. But just remember, it doesn't apply everywhere. Because the pull system corresponds with actual usage or consumption, Toyota is constantly working to achieve the ideal of just-in-time replenishment. Using Kanban, they are carefully monitoring and coordinating the use and replenishment of thousands of parts and tools, orchestrating specific schedules for replenishment, developing rules when to pull the trigger to send a replenishment signal, calculating the maximum amount of inventory that will be allowed, and the like. The Kanban pull system works better than a scheduled system for most business situations, but it still depends on the small inventory buffers or stores of parts, and inventory is always a compromise. So the goal is to eliminate the store of parts and move to a true one-piece flow wherever possible. What that would be an ideal perfect situation or in a Kanban system. A Kanban system isn't something we want to be proud of here. This system right here, although it may be a positive step and a positive improvement and a step in the direction we want to go, the complete end goal is an ideal one-piece flow inventory, which might be your perfect state when it comes to something like this. For instance, let's take our pour-off caps or our pour-off tubes. We may need to pour some type of plasma or serum into a cup and place that cup on the top of a tube before we put it on the analyzer to run it. In an ideal just-in-time inventory system where it's zero inventory and one-piece flow, the amount of pour-off cups that we need would be in that bin based on the amount of tests that we have coming through our system here. And once we use those will be replenished by the amount of tests coming behind that, if that makes sense. And that may be a kind of a difficult or unreasonable way to think. Like, for instance, we have buffers of inventory within these bins themselves, and if we've done a good job of freeing up our space on the outside of our laboratory, then we also have some extra stores of supplies in the laboratory. So we're not having to go to some department or some material supply department to get all of our supplies when we run out, because we have smaller stores within our laboratory, and we've freed up space to allow that. Those smaller stores should be triggered by the amount of stores that we have throughout our production process here. And of course, our specimen processors, they also have a cart that is kind of like a mini store itself. It has some supplies on that they use, and they pull from the actual supply stores. So really, there's an outside pull system going on from those small stores within our laboratory as well. Because the specimen processors are going back and they're pulling supplies as they need them, and then we also had a person in this lab who would continuously monitor the supplies that we had in those small stores, and we would create as much of a pull system around that process as we could. It wasn't perfect. It wasn't ideal one-piece inventory. The perfect state of what you might find a Kanban system. Kanban system is more of something that you want to eliminate than it is something that you want to continuously improve or be proud of. So let's keep reading. A true one-piece flow system would be a zero inventory system where goods just appear when they are needed by the customer, like I just explained to you right there. The closest system Toyota has devised to achieve this is the one-piece flow cell that builds to order only at the precise time the product is needed. And let me just quickly say that in this instance, in this Kanban system right here, we're talking about disposable supplies that we need and pulling those supplies from different stores. Inventory can be anywhere from your actual product itself to your samples to your results. So just put that into context as we read here and kind of see where I'm going. So Toyota has devised to achieve the way Toyota has devised to achieve the one-piece flow cell They use a one-piece flow cell that builds to order only at the precise time the product is needed. But when pure flow is not possible because processes are too far apart or cycle times to perform the operations vary a great deal, the next best choice is often Toyota's Kanban system. Rother and Shook, in a widely circulated book about Toyota production system called Learning to See, say, flow where you can, pull where you must. If you want to design lean systems, repeat this phrase every day when you get up to start the day. You can go far with this simple principle. Where it is not possible to create a one-piece flow, the next best thing to do is design a pull system with some inventory, and that's exactly what we've done right here. This is the next best thing we can do to replenish and use our supplies next to a one-piece flow system, where supplies would just appear as the demand come through, and those supplies would be replaced as they appear, if that makes sense. Consider a pull system in Toyota assembly plant. Orders accumulate from car dealerships. Production control creates a leveled schedule. For example, they make white Camry, followed by a green Camry, followed by a red Avalon, and so on. Each of these cars has a whole set of options associated with it. That schedule is sent to the body shop, where stamped steel parts from a supermarket of pre-stamped panels are welded together into a body. Stamping the panels is a much faster operation than the TAKT time in assembly plants. 1 second per stamp panel versus 60 seconds time in a plant is typical, so putting them into a one-piece flow cell is not practical. They would be productive 1 out of every 60 seconds, so a pull system is used. At a certain trigger point, when a certain number of steel panels have been used by the body shop, our certain trigger point right here is we just notice that the supply in the bin is getting low, so we take that bin and we place it on the bench, like we said, and that triggers our specimen processor to fill that particular supply. When assembly line workers begin to use parts from bins, hinges, door handles, windshield wipers, etc., like they might find in Toyota, in our instances it might be needles, it may be pour-off cups, it may be pour-off tubes, it may be glass test tubes. They take out a Kanban card and put it in a mailbox. And one thing that's particularly kind of nice about this system is if this electronic Kanban system kind of fails, or it kind of goes down, or we need to maintenance it in some way, for some reason if it goes down and we can't use it, we can resort back to a card system where we can just pull out a specific Kanban card or an index card that has this number right here. It has the particular part that we need, and we can start using that system and record all of our data on that card instead of actually record it in this system. In this system, as you'll see here in a second, it's all calculated on their particular electronic Kanban cards. But if this system were to fail in some way and we needed to maintenance it to get it back up, we can immediately go to that index card system. It's not anything complicated. We would be putting the same amount of information on it, which we'll discuss further here in a second, and we could do that in order to get this system back up and running, and at that point we could just enter that data into each one of these cells and we could get right back to where we needed. So I wanted to keep that in mind as I was developing this particular tool, because we know this electronic, and in its nature these things can tend to be unstable. They tend to go down at times. We hope that doesn't happen, but if it does, we can immediately go back to a card system or a Kanban system, as I was explaining here. A material handler will come on a timed route and pick it up and go back to a store to replenish what is used on the assembly line. In this case, our specimen processor again would pick up that bin and fill it up, and she would keep an eye on the supplies on her cart as well. Another material handler will replenish the store based on parts from a supermarket of supply parts. This will trigger an order back to the parts supplier. We haven't gone that deep into this process yet. Like I said, we had an inventory of supplies out here. We had small stores within our lab. but we did not go back as deep as having that part triggered in our supply store, our actual supply department, which were responsible for all the ordering of supplies and so forth and so on. An ideal system would be whenever we were using the parts, they would be replenished by the specimen processor on their carts. They would be replenished back to the small stores parts, and that would trigger our parts department to order that supply. That's an actual Kanban system. It works back not only from our bench space right here, but back to our specimen processor, back to our small parts store, back to our parts department. And we're going to explain how this works right here, just on our bench. This will trigger an order back to the parts supplier and so on. A system like this, where parts in the assembly plant are replenished from a supplier, the process starts at the assembly factory on the right side of the diagram. Of course, you can't see the diagram I'm talking about here, but then withdrawal Kanban and empty containers are sent by truck back to the supplier to be refilled. The supplier keeps a small store of finished parts in a parts store, like we were talking about here, which are used to refill the Kanban. When parts are withdrawn from the parts store shelves, they must be replenished by sending a Kanban in an empty container back to the production cell, where new parts are built and then sent to refill the parts store shelves. Information orders for parts in the form of Kanban flows backwards from the customer, the assembly plant. Materials in this case are sent forward to the customer. It is fascinating to watch this work with so many parts and materials moving through the facility in a rhythm. In a large assembly plant like the one in Georgetown, Kentucky, there are thousands of parts moving about. Alongside the assembly line, there are small bins of parts, and there are small bins of parts that we use throughout our production process here in the lab, are being moved in neatly organized stores. It is hard to imagine how a computer system could do such a good job of orchestrating such a complex movement of parts. When you find out the computer is not doing the orchestration, but rather laminated cards moving about, it's shocking. And in this instance, of course, we are creating a computerized Kanban system. But like I said, if it goes down, we can go right back down to a card Kanban system. And we'll show you how that works, because we've incorporated electronic representation of a Kanban card in this system right here that works neatly. Yet TPS experts get very impatient and very irritated when they hear people rave and focus on Kanban as if it is the Toyota production system. Kanban is a fascinating concept and is fun to watch. I have led many tours of lean plants, and you can spend hours talking about the technical details of many different types of Kanban systems. When is the Kanban triggered? How are the quantities calculated? And we're going to show you all that in here, how we calculated the quantities and so forth. And what do you do if the Kanban gets lost? But that's not the point. And this is important here, what we're moving into right here. While you do have to know those things when you set up your system, they are pretty straightforward technically. The challenge is to develop a learning organization that will find ways to reduce the number of Kanban and thereby reduce and finally eliminate the inventory buffer. Let me repeat that. The challenge is to develop a learning organization that will find ways to reduce the number of Kanban and thereby reduce and finally eliminate the inventory buffer. So what am I getting at here? Basically developing a lean laboratory or developing any kind of lean manufacturing process. Not to say that medical processes are manufacturing. Just go with me here. It's more so about developing a learning organization and developing learning within people than it is about the tools. A lot of people get caught up in the tools, the 5S, the Kanban, the flow cell, the pull system. A lot of people get caught up in developing those things, and they put them into place, and they have a facade of what they might call a lean laboratory, and really they're missing the whole concept if they're caught up in those tools and they wear them as a badge of honor. The whole concept of any lean organization at its core is about developing people. It's about developing a learning organization. It is way more important to have an individual who is willing and passionate about learning and can develop these things than it is to put a whole bunch of tools in place, yet have a staff that's not really willing to take to the next level, if that makes sense. They don't put that passion and effort into a process of learning and training. It's all about it at its core. If you've read any of my previous articles, you might note that I say that the two pillars of the Toyota production system are basically Kaizen, or continuous improvement, which is what this is. Under that umbrella, you would have your tools and your Kaizens, and you'd be able to continue. But yet, it's still about continuously improving, and that has to come from a spirit of learning and respect for people. Those two basic pillars of the TPS are continuous learning and respect for people. And under that umbrella of respect for people comes your willingness to teach, and your willingness to train, your willingness to learn. That has to be in place. It's so key. It's so important. I couldn't have come up with this tool if I wouldn't taught myself how to use this system, if I wouldn't have been able to think through certain processes, if I wouldn't have been able to see that the process wasn't exactly optimal where it was at, although it was advanced beyond what many labs achieve. It wasn't, I wasn't, it's about challenging that. I wasn't satisfied with that. I wasn't satisfied that our specimen processors had to write this stuff on paper, and then we had to take that data and put it into another system. That was steps that I saw as unnecessary. And I wasn't, although we had a pull system in some type of a way, I wasn't satisfied at the unpredictable case of that. I didn't, I wanted to know exactly how many supplies we were using. And it's not to do that as some badge of honor, or to improve that to a point where you say, look what I did. It's not anything like that. It's so that I knew that if we knew exactly how many supplies we were using, then we'd know exactly how many to replace. And if we know exactly how many to replace, we know exactly how many to order. And we can create a little bit of a buffer behind that to kind of address unexpected demand, if that makes sense. And then we can work with that buffer. We can get it really detailed down to the science of everything. Let me read you another passage here. It says, you can effectively use pull replenishment systems in the office to save money and help avoid shortage of supplies. Most offices use some form of a pull system already. Nobody knows exactly how many pencils, erasers, or reams of paper will be used in the office. That's from Toyota Way by Jeffrey Liker again. I wasn't really satisfied with that. I knew exactly, if we knew exactly how many we need to replace, I knew that was an important information, because then we would really have a grasp on that part of the process, so that it could evolve towards a one-piece flow eventually. And so having said it's all about the learning, not so much the tools, I want to kind of show you how this come about. We had a part in our blood bank. It was a triple beam balance in this lab that we weren't using. And we previously used it to kind of measure out transfusion products for babies, because they don't take whole units of blood. However, that process was kind of graduated to ordering specific amounts of blood within that we didn't have to measure off ourselves. So we found that tool in the lab, and we didn't even use it anymore. So what we did is we took that triple beam balance, and it typically might have been red tagged if we were going through a lean cleanup. I want to make the point right here is if you have any kind of inkling whatsoever in your mind that, and I'm not just saying with anything and everything, but if you see a tool that you might can incorporate into a future improvement, then don't get rid of it. Just keep it around, especially a balance like that. It wasn't taking up much room. We couldn't, create a bunch of space because we got rid of a triple beam balance, and it was an expensive supply, and it was the organization's. Basically, if we would have red tagged it, we would have probably given it to somebody that would have been able to use it. They could have moved that resource somewhere within the organization where they could have got rid of it. I don't know what they would have done with it, but that's the whole gist of it. So we put it to use into this improvement. So we took that. If I knew exactly how many of these replenishable supplies, if I knew how much one of those units weighed, then I could calculate how many we used. And that's exactly what we did in our electronic Kanban cards. We put that data in there. We weighed each one of our replenishable supplies within these bins right here, and we calculated how much they weigh, and therefore we could calculate the weight of the bin, and that would tell us exactly how many of those supplies were in the bin. And so let's walk you through the typical process. It was very simple. I think we only maybe have added one more step, but we ended up taking some more out of the process as well. The process as it was before was the tech would see that the supply was getting low. Let's say in bin number 3 right here, they would take that bin, they would place it down on the bench. That would visually cue the specimen processor over here to see that that bin needed to be replaced. That supply needed to be filled, and that specimen processor at that point would take their cart of supplies, and they would kind of roll out here to the back side of the bench. They would replace that part right there. They would replace it right on the bench. The only difference in the process as it evolved was they actually took the bin back to the front up here where they took a measurement, and we'll show you how that worked. So let's say they well, anyway, how the process ended is they would replenish the supply and then would place it back on the bench. It was a pretty lean process. Now, how the process was improved was the tech would notice that the bin was low, they would place it on the bench. That would cue the processor to come pick it up. Now the processor could leave their supply cart up front. They could come back here and they could pick up the bin, and they would take that back to the front. So we did add a few steps in there. However, those coming up with an accurate kind of concept of how many supplies we had and how much we were using ended up saving us down the road. So even though we were adding steps to the process, it really didn't take away. It actually, over the long run, it improved the process, made it more lean. So they would take that bin back up front, and with the low amount of supplies in it, they would place that bin on the triple beam balance, and they would go into our program here. They would see that that bin number had the number 3 inside of it. This number right here is on a sticker with inside that bin. It's 5S, and they would click on that bin, and it would say, okay, well, this is these glass pipettes, right? So they would take some glass pipettes, or actually what they would do is they would hit Control semicolon right here, enter the date, hit Tab. They would put that pre-weight, let's say it's 0.300 or something. Let's say it's 0.240. 0.240. And they would take the bin off of the balance at that point. They would put the supplies in there, and they would place the bin back on the balance to take a post weight. And let's say it filled up to 0.350. They would enter that information in there, and they would tab over, and that would give them a count of exactly how many supplies are in that bin. At that point, they would click on this hyperlink right here to go back to their lab view right here. They would take that bin back to the bench and place it right back on the wall where the replenished supplies. Now let's go over this Kanban card we have right here. This is an electronic Kanban card. If you scroll down, you'll notice it has about 1,000 positions on it. Once all those 1,000 pieces of data get filled up, then you can just go in and record that number somewhere and kind of delete out all your information in there and start over. This Kanban card works by entering the date here, or Control plus semicolon on your keyboard. That'll enter the date, or you can just type it in regularly. And then you tab over and you enter your pre-weight. The specimen processor does, and they would take that bin and fill it up at that point, and they would take their post weight after it's filled up, and that would give you an exact count of how many supplies are in that bin. Now that would be totaled up from this total right here would be the total amount of supplies that's been used ever since this electronic Kanban card has been in place. Like I said, this number right here is a number that's on the inside of the bin, so they know exactly where to go. This is the thumbnail over here. This is the actual supply. You can see it's glass transfer pipettes. And this goes right back to the bin in our bench view right here. As you can see, every single bin has their electronic Kanban card in there, and it has the thumbnail of the supply. This is blue caps. This bin right here has green caps, and everything goes right back to it, to where it needs to go here. And once you click on this, this cursor is always going to be down in the next spot to where you can enter your data and just go from there. So you can go back and click on it right there. So we knew exactly how many supplies we were using in the lab at any given time. We knew how many pencils and erasers we were using. We knew how many reams of paper we were using, because we calculated that. And it didn't take many steps. And if we had to take a tremendous amount of steps to calculate that, that wouldn't make much sense. And it's not to say that knowing that number has any importance in just for the sake of saying, oh, I can tell you how many blue caps I used in a year. That's kind of useless information. But the information was used because we know how many blue caps we've used. At that point, we knew back to the next step in the process how many blue caps were in a bag. We knew how many bags were in a case. We knew how many if we were using a case on our front line right here, we knew to order a case, if that makes sense. So it's a pull system. It goes back through our stores, and that's exactly how this works. If this system were to go down at any given time, there would be kind of a drawer right here you could pull out, and then it would have all these Kanban index cards in there. Those index cards would be labeled with this number right here and the particular supply. So it'd have that number in the supply up here. And then you could put your date on there. You could put your pre-weight and your post-weight. When they took the bin down and placed it on the bench, they would just leave that card with them. And of course the specimen processor would come by and record all that data that she needs to record. It's a very easy system to back up if it goes down. And once this system is back up and running, they could just take those cards and enter the information in here as it's needed, and voila, you're right back where you needed to be. And that's how the electronic Kanban system works. It was an improvement to the system we made. I hope you enjoyed it. If I can help you develop any tools like this in your laboratory, please do let me know. My email address is rhall95@liberty.edu. That's RHALL95@liberty.edu. And you can connect with me on LinkedIn. You can follow my tweets at CL Tweetnologist. And you guys have a great day.